Hello and welcome today, and thank you for joining us for our webinar on verifying de-energization by I Gard Corporation. Today's session is going to look obviously at the verifying of de-energization, and we're going to be doing an overview of how you keep your employees safe at work, looking at the codes and standards around this and the difference between absence of voltage testers, ports, and such. With us today is Sergio Pineda. He has a BA and master's degree in electrical and electronic engineering from McMaster University. He also has extensive expertise in automation, control, switchgear design, and protection relay design, which has given him an excellent resource for his position as Vice President of Engineering at I Gard Corporation. Mr. Pineda is also a registered professional engineer in Ontario, a designated consulting engineer, a member of the Institute of Engineering and Technology in the UK, and a senior member of IEEE. With that, I will get out of the way and hand the presentation over to Mr. Pineda as he will walk you through this very important information. Over to you, Sergio.
Thank you, Owen, for that gracious introduction. I wish all my introductions would be that way, but more often than not, they're not. So we're going to discuss the absence of voltage tester and verifying the energization, the de-energization, and it's sort of a call to arms, shall we say, because what we found over the past 13, 14 years is although the industry has done a great deal of work with arc flash energy and protecting people against arc flashes, we found that more and more people are not adhering to the rules and are still getting shocked. As a matter of fact, from 2011 to 2020, the rate of non-fatal injuries due to exposure of electricity remains relatively unchanged. So whatever we're doing in the industry right now doesn't work. The table to the left establishes, are for establishments not specifically manufacturing, but tend to have a second highest incident rates after construction. So people are still getting shocked due to incidental contact with live conductors. So although the industry is working really well with arc flash, where people are getting hurt is shock. And what we're trying to introduce is the absence of voltage tester, which will assist in that. So really, since 2011, we could see that we're not really decreasing in the trend the way arc flash has. From 2003 to 2019, there were 1,910 electrical burn injuries. That's this number right here. These incidences receive a lot of press coverage due to the devastating nature of the arc flash and with the onset of some of the standards and guides that are used to prevent that. Yet during the same period, there were 4,010 electrical shock incidences in manufacturing facilities, while 50% of the victims only missed 1 or 2 days of work. More than 25% of the victims missed 3 weeks or longer. Again, this reinforces the nature that we're doing a tremendous job with arc flash, but really we're not addressing shock as a hazard. Perhaps the greater concern is that there was an increase from 2019 and 20 in the number of incidents that were related to installation, maintenance, and repair of equipment, and that while expectations would be that these were inexperienced people, more than 33% of the workers had more than 1 year experience and 32% of the workers had more than 5 years experience. So we really can't say that these are inexperienced people getting shocked. These are well-experienced people. far as fatal injury with contact of electricity, one positive trend is the reduction of fatalities due to exposure of electricity from 166 in 2019 to 126 in 2020. This might be due to the COVID-19 pandemic and fewer people were working. There is a trend that it's decreasing again, but it's still not decreasing as fast as the arc flash incidences. A vast majority of the workers that are fatally injured were in construction, repairing, or cleaning when they came in contact with electricity. So the 64% here were in construction, repairing, and cleaning. These are supposedly experienced people doing these jobs, and they're getting fatal injuries due to incidental contact with live conductors. So what is electrical safe work condition? An electrical work safe condition, as defined by NFPA 70E, is a state in which an electrical conductor or circuit part has been disconnected from the energized parts, locked out, tagged out in accordance with the electrical established standards, tested to verify the absence of voltage, and if necessary, temporarily grounded for personal protection. So informational note, an electrical safe work condition is not a procedure. It is a state where all hazardous electrical conductors or circuit part to which a worker might be exposed are maintained in a de-energized state for the purpose of temporarily eliminating electrical hazards for the period of time for which the state is maintained. I think one of the questions that was on the preliminary registration was, when do the standards take effect? Some of the national standards, NFPA 70E and Z462 in Canada, take effect the day they're published. You can't grandfather something that's unsafe, like the Canadian Electrical Code or the National Electrical Code. You can't say it was built in 1942, so we don't have to adhere to a safety standard. As soon as the safety standard is in place, it is in effect. There are two references in the United States. We have OSHA, Occupational Safety and Health, and national standards. In the United States, that'll be NFPA 70E. In Canada, it's 462, Z462. OSHA 1910, Occupational Safety and Health Standard 1910.333, selection and use of work practices states the following. 1910.333A, safety-related work practices shall be employed to prevent electric shock and other injuries resulting from either direct or indirect electrical contact when work is performed near or on equipment or circuits which are or may be energized. 1910.333B24B, a qualified person shall use test equipment to test the circuit elements and electrical parts of equipment to which employees will be exposed to, and shall verify that the circuit elements and equipment are de-energized. The test shall also determine if any energized condition exists as part of an inadvertent induced voltage or unrelated voltage backfeed, even though specific parts of the circuit have been de-energized and presumed to be safe. For this reason, we have to have well-maintained documentation, and inside an electrical room, the well-maintained electrical single line diagram must be up to date. This establishes what circuits need to be de-energized or open in order to maintain a properly electrical safe work condition. So safety standards evolved over the years, and some of the recent changes from 2015 to 18 to 21 specifically NFPA 70E. In 2015, the edition only prescribed option to verify an electrical safe work condition was to use a multimeter and test the phase conductors or circuit paths directly. This required opening the door to an electrical cabinet after donning the appropriate safety equipment and making direct contact with the energized parts to verify the absence of voltage. This approach involves risks from unintentional contact and possible current carrying conductors from selecting a meter that is not adequate for the rated purpose. A study in 1995 indicated that 18.3% of facilities experienced a personnel injury when using handheld meters to conduct the test. So you can see in 2015, the only thing that was required to do is measure the voltage inside the cabinet to ensure that it was de-energized. In 2018, we introduced this clause, 120.5, subpart 7, and it basically said the same thing as 2015, except we put in an exception, number 1. And I'm not saying we, like I was part of NFPA 70E. NFPA introduced this. An adequately rated permanent mounted test device shall be permitted to be used to verify the absence of voltage. And we found that it wasn't working because people are still getting hurt. You saw the graphs before. So in 2021, the exception was to read, an adequately rated permanently mounted absence of voltage tester shall be permitted to be used to test for the absence of voltage. So we're not testing for the absence of nominal voltage. This is done for medium voltage. We're testing for the absence of voltage, period, not the absence of nominal voltage. In 2018, NFPA was updated to introduce the option to use an adequately rated permanently mounted electrical test device to be used to verify the absence of voltage, and this led to proliferation of companies using voltage indicators and test ports to conduct this important test. You can imagine what happened. You can use these devices, these are permanently mounted devices, to test for voltage. But they weren't working because people are still getting hurt. So we had to further put in a safety device that measured for the absence of voltage. And in 2021, this is what was done. In 2021, NFPA 70 went through a further update and the term electrical test device was removed and replaced with the absence of voltage tester, with the informational note that the absence of voltage tester must meet the requirements of UL, Underwriters Laboratory, Standard 1436. And according to Underwriters Laboratory 1436, an absence of voltage tester is defined as a permanently mounted test device that is used to verify that the circuit is de-energized prior to opening an electrical enclosure that contains energized electrical conductors or circuit path. An absence of voltage tester is provided with a test circuit with active indications to verify the absence of phase-to-phase and phase-to-ground voltage. And we're going to go through how it does that. The modification of updating the exception meant that you could no longer use any permanently mounted electrical test device to conduct the test. You had to use a permanently mounted absence of voltage tester. So a permanently mounted absence of voltage tester conforms to UL 1436. Those e-devices, permanently mounted test portals, was not an absence of voltage tester, permanently mounted absence of voltage tester. So it's a new, safer, and quicker approach. You de-energize the electrical equipment, apply locks, tags as per lockout, tagout instructions, press the button, test button right here, and the voltage, absence of voltage tester will run through its routine and will define what the routine is later. All three lights, red lights indicate that the voltage is present. Amber lights flashing means that the test for absence of voltage is pending or in process. And 3 green lights means it is safe to get in. Whereas in these particular instruments, the red light off means it's not detecting voltage at this device. Does not necessarily mean you have a safe condition inside. It just means that the light's not on. So applications of absence of voltage testers. Installed on the load side of disconnect switches inside an electrical panel. There are 2 leads to every phase which goes to a particular LED light. There are no connections on the line side. So you have to be aware that even though you're entering the equipment, the line side may be energized unless you put this device on the line side as well. So when you press the button, this is what happens. The supervisory circuit verifies that the phase voltages are off. And this is where the test portal stops working. But the absence of voltage tester continues to work. The supervisory circuit verifies the sensor leads are connected. The supervisory circuit verifies that the energy level on the bus is low enough to conduct the test. The supervisory circuit verifies that the voltage source is sufficient to conduct the test because it has an internal voltage source. Test to verify that AC voltages are less than 3 volts phase to phase and phase to ground. AC. Conduct connectivity check to ensure all cables are connected correctly. Test to verify that DC voltages are less than 3 volts phase to phase and phase to ground. Conduct connectivity check to ensure that all cables are connected correctly. Test to verify AC voltages are less than 3 volts again, phase to phase and phase to ground. Conduct connectivity test to ensure that cables are connected properly. Test to verify that the DC voltages are less than 3 volts phase to phase and 3 volts phase to ground. Conduct connectivity check to ensure that cables are connected properly. Supervisory circuit validates that the tester is functioning satisfactorily after completing absence of voltage test. Visual indication that there is an absence of voltage. So this all happens when the amber lights are flashing. Only when all this is satisfied do we get 3 green lights, and we can safely assume that there is less than 3 volts phase to phase, less than 3 volts phase to ground, both AC and DC. There is proper connection between the pairs of conductors that are connected to the phases, because we've done that several times. There's a known power source which is sufficient energy to conduct the test, and the supervisory circuit ensures that everything is functioning properly. And this all happens within 10 to 15 seconds. So what are the next steps? If installing and using an absence of voltage tester that conforms to UL 1436 reduces risk, saves time, then why am I not seeing that in every electrical panel and motor center? There's a couple of reasons. Misinformation and market inertia and distrust. So misinformation number 1. A voltage test portal provides the same functionality as an absence of voltage tester. The addition of exception number 1 in the 2018 edition of NFPA 70E allows for the use of permanently mounted electrical test device to be used with the market having accepted this approach. The question of whether there's really a difference between the test portal and the absence of voltage tester. Well, here are the differences between the portal and the absence of voltage tester. First of all, the portal is only listed to UL 61010, which is a tool that can be used for measuring voltage. But 1436 is defined as an absence of voltage tester standard that you must meet. So the difference is a voltage indicator has no green light to indicate that the presence of voltage is not present. A voltage test port does not have a supervisory circuit. A voltage test portal does not incorporate a supervisory circuit. The voltage test is a 4-wire test and not an 8-wire test installation. The voltage portal is listed to UL 61010 and does not comply with IEC 61508, which is the standard that is referred to in UL 1436 to achieve an SIL rating of 3. And an SIL rating is a safety intrinsic level. So basically makes sure that the device is functioning properly. And I'm going to speak more about SIL3 later. Absence of voltage tester, according to UL 1436, an absence of voltage tester shall provide the user with a visual indication to confirm the absence of voltage. This is why it has to have a power source aside from the bus so that you can actually indicate the presence of a safe condition after the unit is de-energized. Absence of voltage supervisory circuit shall be incorporated a secondary power source. We discussed that. An absence of voltage tester shall incorporate a supervisory test circuit to verify the tester is functioning properly. The absence of voltage visual indicator shall not illuminate green unless the phase and ground leads are directly contact with the phase conductors being tested. In the absence of voltage tester shall comply with the standard for functional safety IEC 61508 and achieve an SIL rating of 3. So misinformation number 2, a voltage test portal test at the point of work is just the same as an absence of voltage tester. A voltage test portal tests at the point of work just the same as an absence of voltage tester. So according to OSHA 1910-333B-2-4B generally does not permit testing the circuit at the point remote from the circuit element and equipment parts to which the employee will be exposed. A voltage test port is remote from the circuit element to which employees would be exposed and are therefore disallowed. In OSHA provision 1910-333B-2-4B generally does not permit testing the circuit at a point remote from the circuit elements and equipment parts to which an employee shall be exposed, and this disallows permanently mounted test devices such as test ports. Then why would OSHA allow UL approved absence of voltage testers to be used? Exception number 1 on NFPA 70E 120.5 Rule 7 states an adequately rated permanently mounted absence of voltage tester shall be permitted to be used to test for the absence of voltage. We're not testing for the presence of voltage, we're testing for the absence of voltage of the conductors or circuit parts at work locations, provided it meets the following requirements. It is permanently mounted and installed in accordance with the manufacturer's instructions, and test conductors and circuit parts at the point of work. The point of work is a very circuit element to equipment parts to which employees will be exposed and not point remote to them. I guess the point remote to them, you don't basically test an outlet and say your electrical power is de-energized. An absence of voltage tester includes a connectivity check each and every time it uses to ensure the leads are connected to the point of work. As per UL 1436 12.1.7, the absence of voltage tester visual indication shall not illuminate green unless all phase and ground leads are connected. And we put down, we measured to less than 3 volts because that's a requirement of 1436. Misinformation number 3. A voltage test port meets NFPA 70E. One of the public inputs presented to NFPA 70E was to introduce a modification of 120.5 subpart 7, use of an adequately rated portable test instrument and or a permanently installed protective impedance device and a portable test instruments rated for the application to verify the absence of hazardous voltage was introduced. And during public input, this was not allowed to be permitted to be used because NFPA 70E does not test for the absence of hazardous voltage. They only allow the test of absence of voltage. So not hazardous voltage, absence of voltage. And 1436 signifies that the absence of voltage is less than 3 volts. So during public input, the proposal to add permanently installed protective high impedance device was rejected by the NFPA panel, 70E panel. Tackling the market inertia or distrust. Change is difficult. I remember when I was starting out in switchgear, I had the hardest time trying to get people to change from a induction disc protective device to a microprocessor protective device. There was no way anybody was going to accept that. And now everyone is using it. So it's going to take some time. And I remember reading the Electrician's Handbook of 1913, and it says you can test for the absence of voltage by touching the bus. And for extra low voltage, you can test for the for extra low voltage by tasting the bus. So thank God we got away from that. So this is the inertia we're trying to break away from. Is the absence of voltage tester safe to use? How do I know it's installed properly? Are the results reliable? So distrust issue number 1, is it safe to use? An absence of voltage tester display unit is mounted on the door, connected to the control unit via communication cable so that no hazardous voltage is brought to the door. There is no more than 3 volts on this device when it's operational. The absence of voltage tester is installed on the load side of a disconnect switch, and there's no connections to the line side. So this display module, which is brought to the front door, does not have any hazardous voltage connected to it. Distrust issue number 2. How do I know it's connected properly or working properly? There are 2 sensor leads connected to each phase and 2 sensor leads connected to the ground. Before conducting the absence of voltage test, the supervisory circuit built into the tester verifies that the leads are connected by injecting the signal down each and verifying connectivity between the 2 A phases, B phases, C phases, and ground. During the absence of voltage tests, there are 2 separate continuity tests to ensure all leads are connected. And then it goes through all this. So it does the test several times for the connectivity and ensure that the device is working properly. Distrust issue number 3. Are the results reliable? Well, according to 1436, the absence of voltage tester visual indication shall only illuminate green when all phases, phase to phase and phase to ground voltage are less than 3 volts AC or 3 volts DC. The absence of voltage visual indicator shall not illuminate green unless the phase to ground leads are in direct contact with the phase conductors being tested. The absence of voltage tester visual indicator shall not illuminate green if phase leads are connected to ground or if the ground leads are connected to the phase. The visual indicator shall not illuminate green unless the secondary power source is operational. The absence of voltage tester shall comply with the standard for functional safety, IEC 61508, and achieve SIL3 rating. So distrust issue number 3, are the results reliable? Continued. SIL3 means that SIL4 is the highest safety intrinsic level you can have in a system. So to achieve SIL3, an absence of voltage tester must be manufactured using components with the highest functional safety factor and the necessary architecture to ensure that each and every output is verified as per the diagram below. Absence of voltage system testing requirements are specified. Absence of voltage hardware design. So we continually test every device, and we have to supply a probability of failure for each and every device in the circuit so that it's used within its temperature rating, within its current rating, and verify that it will not fail if those ratings are maintained. So we have to be very careful about how we select all the equipment going in here. So to achieve SIL, average failure in hazardous condition, that is 3 green lights incorrectly, has to be less than 1 in 10 million hours of operation. This equates to 1 failure, potential failure in more than 1,000 years. So just to go through a little bit of SIL3, and the high demand operation mode is 1 over 10 to the 7th to 1 over 10 to the 8th. So safe failure fraction, and there was a, believe me, this was a horrendous study to go through, was is this ratio here. So these are all the devices that are in the component. So the failure rate is the reliability parameter, lambda t, of an entity, single component or subsystem, such that lambda t dot dt is a probability of failure of the entity within t to t plus delta t, provided that it has not failed during the time 0 to t. And believe me, I read this thing several times. I still don't understand what it means, but it had to be done. And I'm glad it only had to be done once, because I don't want to do it again. The IAVT has the structure of 2 out of 3, so that no single element indicating that you have a positive output can reinforce that the output is going to be positive. You need at least 2 devices to tell you that the output is proper in order for all 3 lights to turn green. So diagnostic coverage, which is part of SIL3, we have to have a diagnostic coverage of 99%, and we can go through all the math of where this lambda and betas come from, but it's horrendous. So the absence of voltage tester is safer and quicker. Again, going back to exception rule number 1 to rule 3, time consuming and involves risk. Rule 3, if you're going to measure the voltage on the bus with a voltmeter, an adequately rated voltmeter, you're not going to test for DC. You're only going to test for AC. So if you're going to conduct a test according to Rule 7 of the NFPA 70E, 18.3% of facilities experience a personal injury when using handheld voltage test instruments. 36.7% reported near misses of personal injury. 11.7% of facilities experience interruptions to plant operations due to voltage testing incidences. So these are the risks that you can come into by using 120.5 Part 7. By using the exception to rule number 7 and using an adequately permanently mounted absence of voltage tester, conducts the test from the door, so you don't have to don your PPE to enter the compartment and measure the voltage on the bus. The supervisory circuit ensures that the tester is fully functional, and it tests for AC and DC. Now, I see a lot of people doing tests with proximity sensors. And the problem with proximity sensors is that you have to read the rating on them. Some proximity sensors are not rated for less than 90 volts. And I haven't seen a proximity sensor right now that does DC voltage. So you have to pick the right instrument to ensure that you are measuring properly. The absence of voltage tester measures AC and DC volts and does not indicate an absence of voltage unless both AC and DC voltages are less than 3 volts. And it takes 10 seconds. Whereas the meter way takes up to 35 minutes because you have to test for AC and check the meter to a known source. So if I cannot use the voltage test port to conduct an absence of voltage, then why do I need one? The test port is functional. I'm not saying it's a bad thing to use. It's definitely not the right instrument to use for an absence of voltage test, but you can measure many different things. You can measure the voltage on the bus if you're conducting voltmeter tests. You can measure phase to phase, you can measure phase to ground voltages, you can measure voltage unbalances, phase rotation, harmonic analysis, bonding resistance. If you take into account the high impedance lead, resistance measurement test, again, take into account the high impedance lead, and ground continuity test. It is functional as a troubleshooting piece of instrument, but it should not be used as an absence of voltage tester. So to overcome the trust, we've combined the absence of voltage tester here with a portal. So you can use both to feel comfortable till you gain confidence with the absence of voltage tester. So the voltage test provides means for qualified personnel to use their trusted meter to measure the voltage phase to phase and phase to ground. The combination product includes a known voltage source here, so you can measure everything here. Test the voltage, test the known voltage source, test the voltage again. And so you're developing confidence in the actual test device, the absence of voltage tester, while maintaining this. And it takes 10 seconds to do the test. Okay, now we have a little video here, and we're going to go through the absence of voltage tester and the portal with the lights. So the simulator we have here has three-phase voltages, and we can actually open the conductors up to ensure that everything is working properly. Your installation is not going to look like this. Indicate the presence of voltage, you have 3 red lights. And they're fainter now because the voltage on this particular device is low voltage. So we're verifying the connections. That blue light indicates that there's sufficient voltage to conduct the test. And those leads were open, that's why it failed the test. Or the voltage wasn't absent from the system, that's why it failed the test. That blue light will be on all the time. We're just showing it because we're disconnecting it several times. So the voltage is off the bus. And so we got all 3 green lights. That was less than 10 seconds. So we're disconnecting phase 2, or as you guys like to call it, B phase. So A and C are on, B phase is off. And we're showing you that B phase is disconnected, just in case you didn't believe us. So we reconnected B phase, did a test, and everything worked well when it was de-energized. So there's a little capacitor in here that we use, a supercapacitor that we use as an own source. So if you're going to have the system de-energized for a long period of time, that capacitor may discharge. So we have a battery pack that you can charge the supercap from a portable USB-C connected to a battery, and you can conduct the test again. We had one particular customer that basically said they're going to disconnect the switch and come back in 2 weeks to do the test. So the test portal is used to measure voltage and indicate the presence of voltage with the indicating lights. Those indicating lights can illuminate to as low as 40 volts. So below 40 volts, you get no indication. There's a dial on there, so you can rotate the dial and have access to the ports and measure the voltage on the test port. And so we're measuring from B phase to ground, and we get 90 volts. On A, B, and C phase. So it's functional if you want to measure the voltage on the bus. That's a known source. Known source is 3.3 volts. So you verify that the meter works. Next time we have this video, we're going to have music playing beside it. Thank you for attending. Now we'll open the floor, Owen, if you don't mind, to some questions, if you have any.
Yes, Absolutely. We have had a few questions come in throughout the webinar, so as well as some that were provided before. So yeah, we'll take some time. So we actually had a number of questions around this, so we may ask one or two on this. To achieve SIL3, does a redundant power source system need to be provided to ensure that the SIL3 rating is achieved?
A redundant power source? No, you don't need a redundant power source. You just make sure that your power source is built robustly enough not to fail. So you don't need a redundant.
Okay, and then around that actually was a question from several people on what are the recommended or available power supply options for it, and any other communication options available.
We don't have communication options. I know there's a competitor out there that does have communication options, but we don't have any right now. The methodology is basically you're going to be testing every device. I don't want to put in communication protocols and make something overly complicated, because I would prefer, and this is my belief only, that if you're going to test the absence of voltage, you want to make sure that you're standing in front of the gear and you're testing that this section is the section you want to test for the absence of voltage tester. I've heard horrific stories about people shutting equipment off at the front of the gear, walking around to the back, and you have look-alike equipment, and you walk into the wrong cell, and a tragic event takes place because you weren't testing that particular cell. So to have communications means that you want to test things remotely, and I would feel more confident that it was local to the equipment where you're doing the test.
Gotcha. And what about the recommended power supply options?
Well, our power supply that we're using for the test for the combination unit is about 3.3 to 5 volts.
Okay. And are the ABTs intended? Oh, sorry, go ahead.
I didn't mean to cut you off. What we want to do is ensure that the voltmeter is functional.
Okay, perfect. Are the ABTs intended for low voltage only?
They are. Right now, they're intended for low voltage only. The problem with medium voltage, and believe me, I've been asked if we can come up with a medium voltage unit, is the more instruments you put between the absence of voltage tester and medium voltage equipment, the more probability of failure you have. So if you have potential transformers, then they're fused. So is the fuse blown? Is the transformer working? And I'd rather have a higher confidence level of knowing that the bus is, we're connected to the device that we're actually testing, and not developing a potential that we can measure from then. The only thing I'm going to verify if I introduce a voltage transformer is that the secondary of that transformer is de-energized. I'm not going to make the assumption that the primary is de-energized. And no, but I don't think anybody would.
That's fair. You know, we've got a few questions that are a little maybe more difficult to answer. I know in the beginning when you were talking about the injuries, we had an individual that was just curious. Is it known if the severity of injuries has decreased, even though the quantity of injuries has only slightly decreased?
I don't know that information, but
No, that's okay. Certainly that would have to be looked at case by case.
Well, we do show the non-fatal injuries and the fatal injuries, right? So these are non-fatal injuries, and these are fatal injuries. So the fatal injuries seem to be reducing, but in some industries, but the non-fatal injuries are basically pretty steady at around no less than 2,000. Well, maybe 2016, it was 1970. So.
Yeah, understood. Now, again, you may have touched on this, but what is the maximum system voltage that the tester can be used on?
We have it UL listed, or we have it listed to a UL standard up to 600 volts, but we can use it on 690 volts. And that was a limitation of the standard, not a limitation of the equipment.
Okay, interesting. Does the absence of voltage tester require maintenance or testing of the system itself, and what's involved with that?
There's no real testing per se that you can do on the absence of voltage tester, other than, you know, shut the power off and hit the test button and see if it works. I mean, there's no calibration, there's no maintenance procedure. It's plug and play.
Interesting. All right. Yeah, we've got a couple of questions coming in as we're asking them here. Is the tester of multiple channels, or in other words, what if one wants to measure upstream and downstream the disconnecting means? What is your recommendation on this?
I thought about that, but I would rather place an absence of voltage tester on the disconnect switch feeding the device I'm on. That way, I only need one to disconnect many feeders, and I will test for the absence of voltage there. Now, when you're downstream, you can verify the absence of voltage by hitting the test button again. But if I have one upstream and downstream, the issue there is to ensure that people don't make errors, because 90% of the, I'm not going to say 90%, a lot of percentage of the time, people have a false sense of security. So if I'm measuring the load side of a switch, but my voltage indicator is connected to the line side of the switch, I don't want them to believe that it's de-energized on the line side of the switch. So I'd rather have a single source to remove a false sense of security. So one device, one connection point.
Understood. Thank you. And does the AVT device detect stored energy after the power is removed from the equipment?
It will only indicate 3 green lights if you have less than 3 volts AC or 3 volts DC. That includes any stored energy that's on the system that's greater than 3 volts. If you have greater than 3 volts, you're not going to get 3 green lights.
Gotcha. Thank you. And is the tester affected by frequency?
No.
Okay.
Okay, let me answer. I haven't tested it at 400 cycle, so I'm not sure how to answer that. Harmonics don't really cause a problem, but I think with more and more people gaining interest on absence of voltage, we have had a lot of calls for people wanting to test the absence of voltage at 400 hertz. I don't believe I've tested it at that level yet.
Understood. And now we have a code related question here. Are test ports not allowed anymore per NFPA 70E, even though they are UL listed to 61010? And does the NEC allude to absence of voltage testers directly or indirectly?
If you look at, I'm not going to say whether it's allowed or disallowed. I'm going to only give you I can't interpret the code for you, but I will let you read it. And it basically says here, in 2021, the release of NFPA 70E says that use of an adequately rated portable testing instruments to test each phase conductor or circuit part to verify it is de-energized to test each phase conductor or part of phase to phase and phase to ground before and after each test. Exception number 1 is an adequately rated permanently mounted absence of voltage tester, and part of that requirement is to be tested to UL 1436. So I believe the test portal is tested or certified to UL 61010, which is not UL 1436.
Gotcha. Thank you.
I would say no, but only because that's my interpretation on NFPA 70E. You could say that's a reasonable expectation of NFPA 70E, but I've been fooled many times before.
Fair enough. Again, a little bit of a tricky question here possibly to answer, but with the absence of voltage tester and the advantages that it provides, in your recommendation, should this replace all older voltage test devices?
I said earlier that the voltage test devices have purpose. They can be used to test for the presence of voltage, the quantity of voltage. Again, we have a guide over here of what you can do with a test of a voltage tester portal. You can measure phase to phase. You can measure phase to ground. You don't need to open up the cabinets to measure phase to phase or phase to ground. You can measure phase unbalances. And so these are in accordance with NETA standard and NFPA 70B. It has its purposes. All I'm saying is it should not be used to test the absence of voltage, according to my interpretation of NFPA 70E.
Gotcha. Thank you very much. And as we're nearing the end here, I'm going to ask the one final question that has come in, and that is, what is looking at around sort of the cost and the availability of the units, and how long or what is involved for one to install it on their device once they receive it?
The display unit is a 30.5 millimeter knockout, and we have a quick connect cable that connects from the back of this unit to the control unit, and the control unit has 8 wires connected to it, 2 per phase, each phase, and 2 for ground. I can't tell you how long it takes to install it, but it seems like it won't take a long time. If you can install a portal, you can install this.
Gotcha. And what about availability for the units or lead time on them?
How many do you want? I have them in stock.
Roger that. I think that answers the question.
I think with price, I guess what we're going to do is we're going to send all the answers to all the questions that are answered to everybody that's in this presentation. We will, I guess, send you a price list. And you can determine from that whether you want the absence of voltage tester only or the combined unit.
Perfect. Yeah, no, that's fantastic. And yes, as people have been asking questions, we have been letting everyone know that they will be receiving a full detailed response on all the questions that have come in, as we have addressed most of them, but certainly there have been a number of others that have come in. But as we are nearing the end of our time here, I would like to say, thank you so much to everyone for attending today. Yeah, thank you very much, Sergio, for your presentation and providing all the detailed responses that you did, and for tackling all of the questions that come out of the blue. Again, if anyone has any additional questions, feel free to reach out to either my email, which was on the registration, or directly to iGard, and we will then also reach out to you after providing all the responses and a recording to the webinar today. So thank you so much for everyone. Thank you, Sergio, and everyone have a fantastic rest of your week.
Thank you, Owen. You too. Good luck fishing.
Thank you very much. Have a good one. Goodbye.
Bye.